Hi there, how's it going? Terry Brown, Mechanical Engineering here, again with another engineering mechanics video solution. So let's go look at the problem. Alrighty, so here we have a beam with a couple of loads acting on it, and we're asked to determine the couple moment that is acting on this beam. So we've got a force up here and a force down here. They're both the same magnitude and they're parallel to each other. Okay, which is the definition of a couple. So we just got to find the magnitude of this couple. So hopefully not too difficult a problem. So our solution, firstly write down the equation or formula for couple. So the moment is equal to sum of the force times distances. So for a couple, we can just work out the force times the distance between the two forces. So hopefully you remember that as the definition of a couple. So probably in this case, it's easiest to find perpendicular distances between the components of the forces that we're given. Okay, so we could do something like this. Let's draw a line on here. So extend the line of action of one of these forces, something like that. And then the line of action of this one here is parallel. And then we could try and work out that perpendicular distance there between them. All right. So that's a little bit tricky trigonometry to do that. So seeing that we're already given this vertical dimension here and this horizontal dimension here between the locations where the forces are applied, makes sense to just make use of those. So let's do that. All right, so just redrawing the problem and putting on my forces here. What we need to do now is to find our components, and we're given the forces directions as using this 3, 4, 5 triangle, and you'll see this a lot in textbooks. And also it's a useful thing to know, to get something square. We've got magnitude of 10 kilonewtons for our forces. So putting on my components there, this one down here, using our ratio of our triangle. So the horizontal component here will be 3/5 times 10, and the vertical component will be 4/5 times 10. I think I've drawn them down here on the other side as well. Okay, so let's make use of the equation. So the moment is the sum of the couples, force times the distance between each of the forces that are equal and opposite and parallel. So we're starting off here with the vertical ones. So the vertical components, 4/5 times 10, and the distance between those two forces is 4. So we have that there. Taken anti-clockwise as positive. Okay, so I think just by looking at this, you're going to be able to see that this is going to be clockwise, and so therefore will come out negative. But if we look at this force down here, let's say we take, that's the other thing to note. Usually when we're calculating moments, we indicate the point we're taking moments about, right? But because in this case we have couples, right? So either the original couple or the two couples, because we've got the components, we know that no matter where we calculate moments about, we're going to get the same answer. So if you're not sure about that, just go through the exercise, right? Take moments about this point here, maybe take moments about a point midway between the two these two vertical bits of structure, and then take moments about this point and see that you get the same answer. But because I know that the magnitude of a couple is just the force times the distance between the two forces, I'm just going to use that. So here, distance between the two vertical components is 4, and that's going to be tending to rotate around that way. Right? So hopefully you can easily see that. All right, so let's move on to the horizontal components. So this time we have 3/5 times 10. So that's our horizontal component up here and the horizontal component down here. And looking at that, we can see that that's going to rotate around that way. So we can see this force pushing here to the left, and this one to the right. So if we take moments about a point in between here somewhere, that's going to tend to rotate that anti-clockwise. So that one's a positive moment. And if we put all that into our calculator, and we get minus 20 kilonewton meters. So alternatively, we can do something else. So what I've done here as an alternate solution is to consider, all right, well, this force here is going to act down through this line of action, and it's going to intersect this horizontal line here at this point here. Right, so this little triangle here will have the same ratio of sides as the original triangle for our force here, because it's the same line of action. So I can easily work out this little horizontal distance here is just going to be not 3/4, that should be 3/5. I wonder if I change that in my solution. Oh, no, it should be 3/4, because I don't have the hypotenuse here as 1. I have this vertical side here as 1. So that's why I've used 3/4 here rather than 3/5 like I did up here. So that will be the same on the other side. So now we can just do, so all we need here is the vertical component, 4/5 times 10. And then the horizontal component will be here. If we do the same thing down the bottom, then we can see that the two horizontal components are now collinear. Right? So no moment generated, or no couple moment generated by the two horizontal components. You just have the vertical components and this perpendicular distance here, which will be 4 minus 2 times 3/4 times 1. Okay, so we've got this bottom edge of this blue triangle, and we'll have the same over here. Okay, so that's what we've got over here. So if we put that into our calculator, we get 20 kilonewton meters. Right, and this time I've just put here, right, because I know that it's going to be clockwise, I've just put clockwise as my indication here, so we get positive answer. All right, what you could also do is what I showed at the start, trying to find the perpendicular distance between these lines of action. So if I continue that here, and we find that perpendicular distance in between, then you can do 10 times that distance. Okay, and if you get your trigonometry right, what should that distance be equal to? It should be equal to 2, right? Because we've got a force of 10 kilonewtons up here. So 10 times D should be the same as what we've calculated previously. Okay, so that's it for that problem. Hopefully that was helpful and interesting, and helped clear up some things about moments and couples and how to calculate them. All right, catch you in the next video. Bye for now.